This is chapter 16, which contains some additional strategies that are really useful but didn't really fit in any of the previous chapters. So I want to cover 5 strategies here. Number 1, we'll talk about how to handle uniqueness on 2 or more attributes. Second, we'll talk about handling sequential identifiers. Third, we'll talk about pagination. Fourth, we'll talk about singleton items. And then fifth, we'll talk about reference counts. So let's get started with uniqueness on 2 or more attributes. And whenever you want to assert uniqueness on something in your table, you're going to have to build that into your primary key, and then you're going to have to use that condition expression when you're writing that item to the table to make sure there's not an item with that primary key already. So just an example of what that might look like, imagine your users, when you sign up, you want to have unique usernames across your entire application. Our table might look like this, and here each user item is going to use a partition key and a sort key that's user hash and then username, and it contains that username in there, so then when we're inserting that item, we can make sure that someone else isn't already using that username. Now, imagine you have 2 attributes that you want to make sure are unique. Like with this user, you might want to make sure the username is unique, but also the email address is unique because you don't want someone signing up with multiple email addresses on your service. You might be tempted to do something like this, where you build both the username and that email property into your primary key, maybe one into the partition key, one into the sort key, but that's not going to work for you. What that's going to do is it's going to make sure that the combination of those 2 is unique, but it's actually going to remove that prior uniqueness requirement you had that said, hey, this username needs to be unique, because now if someone signs up with the same username but a different email address, they'll be allowed in this table. So we're going to do something different. Instead of building both attributes into one primary key, we're going to create a second type of item, and that second type of item is just tracking that uniqueness. So you can see here at the bottom, I've added a couple user email items that have that email built into that item, and then I can assert, hey, when I put this in, I can make sure that no one is using that email. So the key point for uniqueness is that you're going to need an item type for each unique attribute that you want to maintain in your table. So we have one for username, one for email. Now, what you do is you wrap that in a transact write item operation when that's created. So when someone creates a new user, what you'll be doing is creating both of those items, that user item and that user email item. You'll be asserting that attribute not exist condition on both of them. And then if either one is already being used, it's going to be rejected, which will roll back that entire transaction. Let's take a look at that in code just so you know what we're talking about here. So here we have our transact write item operation. We're putting in a couple transaction items. This first one right here, this is our first transact item. We're going to be putting in this thing into our users table, and this is going to be that actual user's object. So it's going to have the user with the username. It's going to have a lot of attributes about that user, and it has this condition expression to make sure that that attribute doesn't exist. So we know that there's not a user with that username already. At the same time, we're putting in this second operation as well. This is that user email item type where we have the email built into that primary key, and then we can use that condition expression again on that one to say that email isn't being used either. And now if either one of those fails, it's going to be rolled back. Last thing I want to note here, if you look at that user email item, it doesn't have those other attributes on it like username, first name, last name, date of birth, all that. If I'm only using this item to assert uniqueness, but I won't be doing lookups by that attribute, if I'm never going to be looking up a user by their email, it's fine to just have this bare item like this. Now, if you're going to be doing lookups by that email or by the username and you need to do both, that means you're going to need to maintain both attributes on both ones. So every time you update that user, you'll need to update both that user item and that user email item. So make sure you understand the needs of your application there. Now, the next strategy I want to talk about is how to handle sequential identifiers. And with a lot of relational databases, as you're adding items into a table, you're getting this auto-incrementing sequential identifier to recognize that item. That's a common pattern to use with relational databases. It's a little trickier with DynamoDB, so I would just say avoid this if possible. But you do see some places where you want to have this sequential identifier. And I think it comes up a lot in project management software. So if you're thinking about Jira and you create a project and each ticket within that project is going to get this incrementing identifier. Same thing happens with GitHub and issues and pull requests, where when you create a repo, each issue that you create after that is just going to have this incrementing identifier. So if you do have requirements like that, this is how you're going to do it. It's going to be a 2-step operation. First, what you're going to do is have a parent item that is maintaining that counter. So whether that's your Jira project or your GitHub repo, you'll have a counter on that item, and you'll increment that counter first, and you'll return the value from that counter. and then you'll create a new item with that return number. So let's take a look at that in code. What we're doing here, we first have our update item operation. This is operating on our Jira table, and we're specifying the particular project we want to do. So this is that parent item, that project that's maintaining all those different issues. In our update expression, what we're doing is just incrementing this count. So we have this counter, we're setting it equal to the value of the current count plus this increment of 1. And then what we're doing there finally is we're saying, hey, give us the updated new return values, which means all the attributes that we updated in this operation, which is just that issue count number, give us the new values of it. When we get that back, then we can pull off that current count value based on that issue count number. Now we know what it is after that operation. And now we do our put item request where we create our new issue in that project. We use that current count in there, and then we give it the other attributes like the issue title, whatever else you need. But now what you've done is you've incremented that original project to find out what number you're on, and then you go out and create that item. Now, again, I'd say avoid this if possible because you are making 2 serial requests that need to happen one after another, so it's going to be a little bit slower. But if your application requires this sort of sequential identifier, this is how you can handle it. Let's move on to the next strategy, which is around pagination. So often if you have an API that returns a lot of results, maybe you'll return a first set of results, maybe 5 or 10 or 25 results, and then users can follow up for subsequent pages to get additional results. Now, if you're working with a relational database, you'd probably write something like this where you have that at the bottom, that limit 10 offsets 10, which says, hey, limit 10, I only want 10 results, but offset 10, skip those first 10 results because I'm actually on the second page now, and that'll give me that second page of results. Now, DynamoDB does have that limit qualifier, but it doesn't have that offset qualifier, so you're going to need to handle it a little bit differently. Let's look at this by way of an example. So here we have an e-commerce store where a user is going to make multiple orders over time. You can imagine that fetch orders for user endpoint returns maybe 5 orders, the 5 most recent orders initially, and then you can paginate through and get additional orders as needed. So let's implement that first request in code just to see what that looks like. We have our query operation here, and we're working on our e-commerce table. Again, we've got our key condition expression where we're matching the PK for a particular user, and then we're saying we want all of them where the sort key is less than this given value we wanted. For our sort key, we're just starting at the very end of those orders. So we're saying order and then $, which is going to get after all the order items. And then we're just saying, hey, give us 5 of those because we only want to return 5 on that first page. If we go back to our table, we've got our table with all these different orders in it, and that first request is just going to get those 5 orders starting at the bottom and working backwards because we want to do reverse chronological order. Now, what if we want to go on to that second page and just get that next order item? We can handle that in code as well. Here's our query. Again, it's the exact same key condition expression and everything. The only thing we've changed is this sort key value that we're comparing against, where we're looking at the last order that we saw there and saying we want our sort key to be less than that because we've already seen this particular order. So when you're implementing this API, you may need to send hints back to your backend about what's the most recent item that you've seen. Rather than doing, give me page 2, you might say, what's the last seen? So here's the URL we might use for our API. Again, we've got that username built into the path there, so that's the specific user that we want. But we also have this query parameter of before equals, and then we have the last order ID that we saw. And then we can plug that into that query and say, okay, they want more orders. They want 5 more. This is the last one they've saw. The last one they've seen, they can start there and go backwards. So 2 big tips you need to think about with pagination. Number 1, use that limit parameter to retrieve a specific number of items. And then second, add hints into your API to give you the last seen key. So make sure that's getting passed back so you know where to start off as you're paging through these items. The next strategy I want to talk about is one that I call singleton items. This is kind of a unique one. And just to give you a sense of what I'm talking about, when you're creating your DynamoDB data models, you have these different entity types, and usually there's something, some kind of parameter built into that primary key, so you can have multiple instances of that particular item type. So if we go to that movie roles table that we've done a bunch of times, in each of those primary keys there, we have different parameters. So in that role, we have movie name and actor name that helps make that unique, and we can have a lot of different roles with that same primary key. Now, sometimes you'll create a type of entity that doesn't need that sort of customization. Maybe you only need one instance of it across your entire table. Here's an example here. Imagine you're using DynamoDB as some sort of job status queue, and you have all these different jobs. Those are outlined in red, but you're also sort of tracking the number of jobs that are actually running at any given time, and you want to make sure that doesn't get too high. Maybe you only want to run 10 or 100 or whatever number of jobs. what you can do is you have that jobs item that you're just adding in jobs into that jobs in progress attribute, which is a set, and keeping track of that status. And if you look at that jobs item, notice that the primary key does not have any parameters in it. It's just a static value of jobs for both the partition key and the sort key. And I call this a singleton item because there's just one instance of that particular item across your entire table. We see a few examples of this in the deals example later on as well. Now, the key with singleton items is that here you have a global item without any customization. You're using it, just one instance of it across your entire application. The big thing you want to watch out for is hotkey issues here. So remember that each partition is going to have a limit of 3,000 RCUs or 1,000 WCUs. If you have everything that's just hammering this individual singleton item across your application, that could run into those issues. So make sure you know your access patterns there, that it's not going to get bombarded too much before you make this global item that everyone's hitting. Last pattern I want to talk about here is around reference counts. And what you have here is you have a parent item with a lot of related items where you want to maintain some count of the number of related items there are. So the example here is Twitter. You can imagine, everyone tweets a lot. That's the parent item, but it also can be retweeted and liked a lot. And if you have these very popular tweets like this one that Ellen DeGeneres had at the Oscars a few years ago, it got millions of retweets and likes. So it wouldn't be very efficient if every time you wanted to show this tweet, you went and queried all the retweets and all the likes to see how many there were. You're paging through millions of items there. That's going to take a long time. So instead, we're going to use this reference count strategy, and this is how it works. Again, we're going to maintain that count of the related items on the parent itself. And this is usually done with a transaction. When you're creating that related item, we'll use a transaction. We'll be doing two things. Number one, we're actually creating that related item itself. So we'll create that retweet, we'll create that like, whatever it is, because we want to make sure there's uniqueness on that so that a user doesn't like a tweet multiple times. Secondly, in that transaction, we're also going to increment that counter on the parent so that we know how many related items there are. So let's take a look at that in code. Again, we're using that transact write items here, putting in a couple different transaction items. The first one we're going to do here is a put, and this is actually just creating the retweet itself. So here we're saying which tweet we're retweeting, we're saying which user it is that is doing it, and including some information there. The important part here is we have this condition expression to make sure that this item doesn't already exist, because we don't want to allow a user to retweet multiple times on the same tweet. In that same transaction, we're also doing this update operation, and this is going to the tweet itself. And we're making sure that that tweet actually exists. And then when we do that, we're running this update operation where we're just incrementing that retweet count. So we're setting that, we're looking at the current value, setting it equal to the current value plus this increment. We've used this pattern a few different times, and then we're making sure to increment that count. So now every time we create this related item, we're also incrementing the counter on that parent. So then when we fetch that parent item, that tweet or whatever it is, we can show that count without having to go count all the related items. That concludes this chapter where we looked at 5 additional strategies you might want to use. Just a summary of what we covered here. Number 1, how to handle uniqueness on multiple attributes. Remember, we said to create a tracking item for each of those attributes to make sure that you handle that in that primary key. Number 2, we talked about how to handle sequential IDs using that 2-step process of first incrementing that parent and then using that value that's returned to create that new item. Third, we talked about pagination and passing back hints to your API to indicate where you left off. Fourth, we talked about using singleton items. And then fifth, we looked at using reference counts to store the number of related items for a particular parent item. That concludes our section on strategies, where we looked at a lot of different patterns that you're going to be using in your DynamoDB data models and how to handle those, how to think about those. The next section we have, the last section of the book, is all about data modeling examples. We're actually going to work through some real examples. We're going to build out our ERD. We're going to list our access patterns, and then we're going to model our DynamoDB tables. So go check those out.